Hello class, this is Ms. Riggins with today's video on section 7.1 and 7.2, the periodic function and the sine and cosine function. As you're watching the video, please remember to write down important information, take notes, write equations or formulas or any questions you have. Feel free to pause, rewind, or even replay the video as often as you need so that you get a full understanding. And at the end of watching the video, don't forget to write down your online summary, your summary, and then submit it online via the WISC form as well as your top question. Before we get started, I would like to thank everyone who participated in Teacher Day. I really appreciate the lovely statements that you guys made on my poster, and I really enjoy being your teacher, and I really enjoy you guys as students and teaching you mathematics, and I promise to continue to do the exact same thing for a long time. Okay, all right, let's begin with today's video. Today's video actually has a video in it, and it's going to be a video about, let me bring it up, the London Eye. And for those of you who don't know what the London Eye is, it's a Ferris wheel in London, which is the biggest Ferris wheel in the entire world, from what I understand. The diameter is 450 feet, and this is a time-lapse video. Let me turn it down a little bit. Of the Ferris wheel moving throughout the day. And as you can see, it's going all day. It's around in a circle, around in a circle. If we were to measure the height of a particular cab as it goes around the circle, as you can see, the height of that cab, from the distance from the cab to the ground, is changing, but it's repeating itself over and over again. So how does that apply? Well, we're going to be looking at a function based off the Ferris wheel function, where f is the height above the ground t minutes after the wheel starts, if I'm in a particular cab, okay? And sometimes it helps to get an idea of this Ferris wheel problem by looking at a clock. And at time 0, the position of the cab would be at, let's say, 6 o'clock position on the clock. And then since it takes 30 minutes for a cab to return to their original place on the Ferris wheel, then at time 7.5, it's a fourth of the way. So this position would be this far from the ground, and vice versa at time 15 minutes, which the position of the clock would be 12 o'clock. It would be 450 feet from the ground because the diameter is 450 feet. And then when it comes up here to 3/4 of the way around the circle, the position is at 9 o'clock, which is this distance from the ground. And if you take a look at it, 9 and 3 o'clock are on the same level as the center of the circle. So really the distance from the ground would be half the diameter, or the radius, which is 225 feet. So let's take a look at a scale here to track down this information on a table. And what happens after the first 30 minutes? The Ferris wheel doesn't stop. As you saw in the video, it keeps going. So we can add more values to our table. All right. And then that's after the next 30 minutes. And we can even add more for the next 60 minutes for a total of 120 minutes. But one thing that you notice about the height above the ground is that it is repeating. Certain values are repeating after so long. So if I were to graph this table values, here we have a table. I'm going to add myself a lovely data and statistics page. And I'm going to take the x-axis to be time and the y-axis to be height. Graphing those values for the 120 minutes looks something like this. And the question is, what kind of function do you think this is? And some of you may say, well, it could be absolute value, but absolute value only has one v symbol, and this has a whole bunch of v symbols. Some of you may say it's a piecewise function, but really we need to see what's going on in between these 2 points. And when we do that, we'll get a better idea about what the function looks like. So let's take a look and define what a periodic function is, which, as we can see, a periodic function is a function whose values repeat on a regular interval, or a period. And actually, if I were to take more precise values in between every 7.5 minutes, then I would see that the graph really doesn't look like a bunch of absolute values. The graph actually looks something like this. Okay? Let me move this up so you can see. Now we talked about being a periodic function, which means it repeats every certain time frame, and in our case it repeats every 30 minutes of the Ferris wheel because that's how long it takes for a cab to return to its original position. So the period is 30 minutes, and how do I know it's 30 minutes? Because I can see that this value repeats itself here and here, which is a distance of 30 minutes. Or this value down here repeats itself from here to here, which is a distance of 30 minutes, or from here to here is 30 minutes. But you have to be careful and make sure you select more than just a couple of values, one pair of values, because as we can see, this value repeats itself not every 30 minutes, but every 15 minutes. So that occurs when we have something that's not at the peak or at the valley. So when you want to determine the period, don't take a look at any value in between. Look at the values that are the highest values on the graph or on in the table, or the lowest values, and see how often those lowest values and those highest values repeat. Don't pick in between, because in between you're not going to have the same length of period. Okay, it's the same period for the graph, but these don't measure. The in-betweens don't give you an idea for the length of the period, only the peaks and the valleys. So that's how you determine the period. The amplitude is how high the graph is, and sometimes it's misleading because people say, oh, this is 450 feet because this is how tall the graph is. But actually, when we talk about amplitude, since we're repeating things and things go up and down, really the amplitude is really half the distance between the lowest point and the highest point. Okay, and that's called the amplitude. So in this case, the amplitude is 225 feet because it's half the distance between the highest point and the lowest point. And the midline is the line that we use to determine where the amplitude is, or where basically halfway point is. So I don't really use midline a lot, but I do use and will use period and amplitude a lot as well. Okay, so this is that graph. We're going to talk about a couple of things to get us situated, and I don't know if you guys know this already, so I'm going to pretend you don't, or you do. You don't know it, okay, which is the sine and cosine function. And they define it as, if we were to define the height of the Ferris wheel not based off time, but based off the position on the wheel, well, what quantity could we use to determine that position on the wheel? Well, one of the ways you can determine it is the angle that it's produced. So let's say I define that angle to be the angle between the car that I'm tracking and the ground, and the center of the angle is at the original starting point. So as we can see here, we have these 4 different angles that are formed as well. And so each angle represents a position of the cab on the circle. And so we can measure these angles in degrees. Later on, we're going to learn about radians. And this is how we determine the position on the wheel using angles. And usually use angle measurements. We usually use Greek letters to represent the variable, to represent the angles. For those of you who are not familiar with working with angles, we measure angles with respect to the horizontal line, which is this line right here, not to the vertical line. There is a way you can define an angle to be based off a vertical line, but we're going to do it based off the horizontal line. So that 0 degrees represents the 3 o'clock position. Okay, I'm sorry. So anyway, so 0 degrees looks something like this, where it's they're right on top of one another. Positive angles are measured in the counterclockwise direction, which means going not in the direction of a clock, going in the reverse order. If I go the direction of a clock, I'm making a negative angle rotation instead of a positive angle. And then larger angles, i.e. angles that are greater than 360, or angles that are less than negative 360, have wrapped around the circle more than once, have visited the circle more than once, because the total number of degrees in a circle is 360. Okay? So let's take a look at a very popular circle that you guys should learn to be familiar with if you haven't already, which is the unit circle. It is a circle where the center is at the origin and the radius is 1 unit. Okay, it's a very simple circle. The diameter is twice the radius, so the diameter is 2. And some very useful properties occur. Because it's centered at the origin, then its 3 o'clock position is at the point 1, 0. Its 6 o'clock position, 12 o'clock position is centered at 0, 1, vice versa. So we have lovely whole numbers at these important points here. So why is that important? Okay, because there is a way that I can describe the position of the Ferris wheel with relationship to a circle, and more importantly, a unit circle. So let P be a point on the circle, and we're going to call it XY. Then we can define P based off its position according to the angle that is produced between the horizontal line, well, in this case, the diameter, and then the line segment between the center and the point P. And the coordinates of that point can be referred to as cosine of theta, and we represent that as COS. Actually, make this lighter. Cosine of theta, or some people looking at say cos, but I always say cosine. And theta is the Greek alphabet letter that looks like the 0 with the dash in it. So this is cosine of theta. And then we have sine of theta. And not sin, but sine. And that's the y coordinate. Okay? You need to memorize that because that's the case for every single unit circle, that I can find the position of the points on the circle based off the angle. And this is important to note. The x-coordinate is going to be the cosine of the angle produced, and the y-coordinate is going to be the sine of the angle produced. Okay? Very important to note. And why is this the case? This is the case because of the right triangle. And that's why this area is called trigonometry, because it's talking about right triangles. And if I were to draw a right triangle between the radius and then the vertical distance from the the x-axis, and the horizontal distance from the x-axis, then I would get basically the right triangle trigonometry that you learned about in middle school, which cosine is adjacent over hypotenuse, and since the adjacent side is x, the x-coordinate, let me not go to that. Since the adjacent side is the x-coordinate, wrong color, then and the hypotenuse is 1, so x over 1 is just going to be x, which is why the cosine of the theta is the same thing as x, and sine is opposite over hypotenuse, and the opposite is the y value of the coordinate, and the hypotenuse is 1, so the y value is the sine theta. I hope I didn't confuse anyone. Okay, and we use this relationship for that. All right, so this video is getting really, really long, but it's covering 2 units, so that's why it's long, but I don't want to make it even longer than this. Some of this you should already know from middle school geometry, but if you don't, please take a look at this and come and stop by my desk if you have any questions. But I do assume you do know about sine of theta, cosine of theta from middle school. If you don't, please let me know. And